What are we doing today?
Solving polynomial equations in factored form.
Okay.
So
Go ahead.
the first one is x, and then in parentheses, x plus 7, and then equals 0.
Like this?
Yeah.
Okay.
So the first one would be x equals 0. And then it would also be x equals negative 7.
Yeah, this is kind of the most important rule of algebra, is that if you are multiplying multiple things together and you get 0 as an answer, then by definition, one of those things has to be 0. They don't both have to be 0, but one has to be 0. You cannot produce a 0 unless one of these is 0. So what that tells you is with these polynomials, you generally get two answers and they're both valid. Sometimes with equations, especially if you have radical signs, you'll get one of these solutions will be called extraneous, and it's not valid. If you plug it back in, it doesn't meet the requirements for an equation.
Yeah.
All right, what else you got?
12t, and in parentheses, t minus 5 equals 0.
Okay, what's the answer here?
T equals 0 and t equals 5.
Okay, what else?
Negative 2v, and in parentheses, v plus 1 equals 0.
All right, these are all the same basically.
Yeah, or
these aren't, you don't need a tutor for these. You know how to do these. Do you have any that you do not know how to do?
Well, let me see.
In other words, you know that v equals 0 or v equals minus 1, right?
Yeah.
Let's find some that you don't know how to do.
Okay,
It's
so one is...
It's a waste of your time and mine if you just give me problems that you know how to do. That's not doing anybody.
5m plus 4 is in parentheses, and then squared equals 0.
Okay. Which is the same as saying this. Right? That's what squared means.
So both the answers are going to be the same.
Yes, exactly. You're only going to come up with one answer. And how do you solve this? You set that equal to 0, and what do you come up with for m?
Negative 4/5.
You got it.
Wouldn't you have to write down that also double rooted or something?
Well, there's a term in math called multiplicity. And, ooh, gosh, they've changed everything here. Huh, interesting. Never seen this page before. Multiplicity means, gosh, now how do I get back to, all right. If, in other words, when you have something like m squared equals 0, that means m equals 0 or m equals 0. You really have two solutions. It's just they're both the same. The way you talk about that is you say m equals 0 with multiplicity of 2. And multiplicity will become more important to you mathematically when you get a little higher up into Algebra 2 and stuff. In Algebra 1, they don't tend to talk about multiplicity. But that's the case. In other words, when you have a squared equals 0, that means m times m equals 0. And this one could be 0, or this one could be 0, which appears to be one solution, when in actuality you really have two solutions. And it's 0 with multiplicity 2. That's how you talk about that. So in the previous example, we had the answer be minus 4/5, and it was really multiplicity of 2. Now, just for your information, multiplicity does have something to do with the graph. Okay? In other words, if I say x squared equals 0, well, that means x equals 0 with multiplicity 2. And if you have an even multiplicity, that means it's not going to go through the x-axis. It's going to kiss it and bounce off like that whenever you have even multiplicity. Whereas if you have odd multiplicity, let's say x equals 0 only, then that curve is going to hit the x-axis and go through it. So multiplicity definitely affects what the graph is going to look like. And even multiplicity touches the x-axis and turns the other way. Odd multiplicity goes through the x-axis, always. In other words, if I had x cubed equals 0, or let's say y equal x cubed equals 0, well, that looks like this. Get to the 0, and there's 3 of them, which is odd, so it goes through and on up. Whereas when we had y equals x squared, that goes down, comes back up, does not go through the x-axis because it has even multiplicity. In fact, one of the most interesting problems I've ever gotten from a student was last week, where they gave you the graph and made you come up with the function. And it was not easy. It was really hard. And it was based a lot on multiplicity. All right, what else you got?
This is to, we're working on, we have to first factor. We have to factor it.
Okay, good. You can never get too much practice factoring, as I've said to you many times. So what's the polynomial? Let's work on factoring.
5z squared plus 45z.
Very first thing you should, there's 3 things to do when you're factoring something. First thing, always look for greatest common factor. Second thing, always look for difference of perfect squares, dopes, remember? Third thing, quadratic factoring. For the third thing to happen, you need a constant. This does not have a constant. It just has a z squared and a z, but there's no number, which means I can find a greatest common factor. What is it? That's always the first thing you look for, is greatest common factor. And you do it regardless of anything else. If there's a greatest common factor, factor it out. What greatest common factor means is what is the biggest thing that will divide into both of these terms evenly. 5z.
Oh, yeah, sorry.
Notice, if I divide that by 5z, I get z.
So then on the inside of the parentheses, you'd have to have a z. Because you...
Right. That's the way you do these. And as you're factoring it, multiply these back together and make sure you get 5z squared. And you do.
Plus 9?
Yeah. Multiply that back together and you get 45z. Okay? Now, was this originally an equation? In other words, was it equal to 0 or
No,
just an
we have to do
expression?
that later.
Okay. Yeah, they teach it in stages. They have you factor an expression, which is what we just...
Later on in the problem, in the homework.
And if it happens to be equal to 0, now you know how to solve it. In other words, either that's 0 or that's 0. Okay? I'm going to leave those 3 rules up there because those are pretty critical. What's the next problem you got?
6d squared minus 21d.
What should you do here?
Would it be 60?
Does 6 go into 21 evenly? No, it does not.
No.
So whatever greatest common factor you come up with has to divide evenly into both of these terms. Well, what number? What's the greatest number? Let's take the numbers separate from the variables. What's the greatest number that goes into both 6 and 21 evenly? 3. 3 goes into 6 2 times, 3 goes into 21 7 times. And no bigger number goes into both of these numbers evenly. What's the greatest variable that you can take out?
D. Or it's just going to be, yeah.
So the greatest common factor is going to be 3D. What's left over?
D minus.
Hold on. If I write D there, before you do your next step, make sure you multiply those 2 back together to get that. Do you?
Oh, 2d.
In other words, when you make mistakes, you want to catch them immediately. You don't want to finish the problem and then go back and check. You want to be checking, always be checking. So this can't be D. What does it have to be?
2d.
Correct. And the rest of it? What? Minus what? Yeah. And then always be checking. Multiply that times that, you get 21D. Multiply that times that, you get 6D squared. So this method of always be checking is vital for doing math. And it applies to a lot more than just factoring, but factoring in particularly it applies to. You always want to be checking when you factor. That's how you don't make mistakes, is by checking as you go. What else you got?
3y cubed minus 9y. This one it is going to be 3. So.
Okay, 3 is the number. What's the variable?
3y.
Okay. Left over?
It would be negative 3 plus.
Hold on. If I write negative 3, multiply those 2 together. In other words, go from left to right, not right to left.
Oh, yeah. Sorry. Then it would be y cubed? No, not y squared.
Y squared. Multiply those 2 together. Do you get what you started with?
No.
Yeah, you do. 3y times y squared is 3y cubed. So you've done the first part correctly. Now what's...
And then it would be minus 3.
And then that times that does give you minus 9y. So we did it right. Okay, what else?
20x cubed plus 30x squared.
It's the biggest number that you can pull out.
10.
And what's the biggest variable you can pull out?
X squared.
Good. It goes here.
And then it would be 3 plus 2x. Or 2x.
Again, go left to right. You want to go right to left. Always go left to right. You're going to confuse the heck out of everybody if you go right to left. So what goes here? That multiplied together gives you 20x cubed, so that's correct. What's the other term?
3.
Plus 3. You have to put the plus sign in. In other words, you can't just write 3 and assume there's a plus sign there. It doesn't mean the same thing. You have to put plus signs in polynomials, unless it's the first term. If it's the first term, in other words, I don't need a plus sign here because it's the first term of that polynomial. But the second term, I wouldn't know whether it's being added or subtracted if I don't put the plus sign. So you have to put the plus sign in when it's after the first term. Okay? You have any, again, let's skip over the ones you know how to do and get to the ones you're not sure of.
And then that would be the solving equations.
Okay?
4p squared minus p equals 0.
All right. Again, this is not going to be hard because this is a combination of greatest common factoring and then setting each factor equal to 0. So what's the greatest common factor here? Or in other words, when you factor this, what do you get?
Just 1.
Factor it, give me 2 terms. What's the greatest variable you can take? Oh, I see what you meant when you said 1. That's not considered a factor. In other words, I cannot pull a number out, but I can pull a variable out. P. What's left?
-1.
Hold on, go left to right.
4p minus 1.
Right. And now, if that's equal to 0, how do I solve it from here?
Then it would be p equals 0, and then p equals 4.
If we set that equal to 0, solve it. In other words, here's what we have. We have 4p minus 1 equals 0. Solve that.
So then it would be 4 divided by 1, which is 1. So it would be
Hold on. Back up. We're solving this equation.
So you would add 1.
Okay. Let's take it step by step.
Sorry.
So add 1 to each side. So now you got 4p equals 1. And now what next?
Divide by 4.
So p equals 1/4. So there's your 2 solutions. Now, polynomials, if you have a quadratic, you generally expect 2 solutions. And if you have a cubic, you expect 3 solutions. And if you have a quartic, you expect 4 solutions. So there is generally a solution for every power of the greatest. In other words, this started out where the greatest power was 2. That makes it a quadratic. We expect 2 solutions. Now, sometimes quadratics will give you only 1 solution, but it'll have a multiplicity of 2, and it'll just be 1 solution. Sometimes cubics give you, in other words, if I give you this equation, x cubed equals 0, well, that's a cubic. So I'm expecting 3 solutions. I only appear to get 1 solution, but it has multiplicity of 3. Okay?
Okay.
What else you got?
6m squared plus 12m equals 0.
Okay? First step?
Get the greatest common factor.
Okay. So what's the next line?
6m in parentheses m plus 2.
Huh?
And then equal m equals 0 and then m equals -2.
And that's the way most of them will solve. You'll get two different. Now, are all of these problems greatest common factor, or do you get beyond that today?
Well, there is one that I'm kind of confused on. It's so it's a word problem, but I can tell it to you.
That's fine.
So the entrance width of a tunnel can be modeled by y equals -11/50, and then in parentheses x minus 4, and then in more parentheses x minus 24.
Notice that is a quadratic.
Yeah.
If I multiply everything back together again, I'm going to have an x squared as my highest term.
And then it says, where x and y are measured in feet, the x-axis represents the ground. Find the width of the tunnel at ground level.
Okay, so what they're talking about is a tunnel that looks like this. Okay? And this point is 4, and this point's 24, right? In other words, if you were to set this equal to 0 and solve, you would get x equal 4 or x equal 24, right?
Uh-huh.
And setting it equal to 0, the reason you do that is because when we're down here where I made that x and this x, y is 0, correct?
Mm-hmm.
So when you're solving for the x-intercepts, or sometimes called the zeros of the polynomial, you set it equal to 0 because that's what y is. When you're looking for where that occurs, it occurs when y is 0. So if we're solving that equation, we get x equal 4 and x equal 24. What's the width of the tunnel? What's this distance here?
28.
20. The difference between the two numbers.
Oh.
Right? In other words, it's 24 minus 4. See why?
Not completely.
Well, if I'm trying to think of this as a number line, okay, if I gave you a number line and I said, what's the distance between the points 4 and 24, how would you find that out?
Subtract.
Yeah, exactly. That's all you're doing.
Okay, that makes more sense. And then I have another one, and it's basically the same thing, except for we have to find the height.
Okay.
The height as well. So it's y equals -2/315, and then x equals 315, and x.
Oh, hold on. What's the rest of the equation?
X plus 315 in parentheses, and then
Plus
in
315 in parentheses like that?
Yeah.
Okay.
Yeah, and then in more parentheses, x minus 315.
And they want to find the height of the tunnel. Well,
And the width.
okay. What are my zeros?
There are zeros.
Find the zeros by setting y equal to 0 and solving the equation. So set that equal to 0, what do you get for x's?
You would get 0.
No, we've been doing these. This is no different than anything we've done. You got the product of two things equals 0. So x is either equal to minus 315 or x is equal to plus 315. Notice that using either of those answers makes either that 0 or that 0, and one of them has to be 0 at least. Okay? In other words, this is no different than any other problem we've done. You got the product of two things, and this coefficient doesn't really matter. In other words, the fact that there's this strange coefficient there, well, that's not a variable. The only way this product of three things can be 0 is if that's 0 or that's 0. And that produces these two solutions. Well, if I go to graph them, that one's at minus 315. That one's at plus 315. You have a tunnel like that. And what did they want to know? The height?
The width.
The width?
The width and the height.
Okay,
So,
the width.
would that be,
What's the distance between minus 315 and plus 315?
630.
630, exactly. Okay? Now, how do I find this value right there? That's the height of the tunnel. On the y-axis. What's the value of x right there? I'm sorry to use an x. I didn't mean that. I'm trying to figure out that y value. Well, what's the value of x at that point?
Would that be,
Look at my curve. There's the x-axis. There's the y-axis. What's the value of x at my red dot?
0.
Correct. So this becomes really easy. Plug in 0 for x and solve for y. And that's the height of the tunnel. So the height is minus 2 over 315 times, when I plug in 0 for x, I get 315. And when I plug in 0 for x there, I get minus 315. Okay? Well, that cancels with that. Multiply minus 2 times minus 315, and that turns out to be a positive 630. So the height is the same as the width on this particular tunnel. But that's coincidence. In other words, the height is not always the same as the width. It only is that way because that coefficient is structured to make it that way. If I had a typical tunnel, I mean, tunnels come in all kinds of variety. You can have a tunnel that looks like this, where the height is not the same as the width. You can also have a tunnel that looks like this, where the height is greater than the width. So they gave you this problem and structured that coefficient to make the height and the width the same thing. But they wouldn't have to be. You got one more, Logan?
No, that's it.
That's it? All right, that's fine. Okay. I'll talk to you next Tuesday.